Here I'm going to go through a leaving cert question on coordinate geometry of the circle. It came up in 2019, paper 2, question 3. You're given a point and you're told that it's on this circle, so this is one way of writing the equation of a circle. Find two possible values of k. Alright, so the point has an unknown k. Well, if the point is on the circle, then we can substitute it in for x and y. And we're left with minus 2 squared, so just substituting that x value in there, plus k minus 3 squared equals 65. So you're left with minus 4 squared, which is 16, plus k squared minus 6k plus 9 is equal to 65. So rearranging that, we've got k squared minus 6k minus 40 equals 0. So we're looking for factors now. We're just going to solve that quadratic. Factors of minus 40, which add up to minus 6. So we can think minus 10 plus 4. So k minus 10, k plus 4 equals 0. So k is equal to 10, or k equals minus 4. So that's that question. The next one, you're told the circle S is in the first quadrant, touches both the x-axis and the y-axis. The line T is a tangent as shown. Find the equation of S. Okay, so we're probably going to be using some simultaneous equations here. So the first thing to spot with this question is, if I look at the center here, I know that that distance there is the radius. Okay, but the center of any circle, we call it minus g minus f. And in this circle, if we just look at the x coordinate here and the y coordinate, well, as it's touching both axes, the x coordinate here could be minus g, but the y coordinate would be the same distance. So essentially g is equal to f. So we can call the center here minus g, or minus f, because it's the same distance across. They're both touching the axis. Okay, so when we have to move that distance, okay, which is the radius, here that's a distance, a vertical distance, that's the distance of minus f, but here that's a distance of minus g, but they're both the radius, so they're equal to each other. So minus g equals minus f, which is just the radius. So we know that the radius is equal to the distance minus g, okay, because it's equal to the x coordinate of our center. What we can do then is, as we know that's a tangent, we're going to have to use this line. We've got the equation of it here. That's a radius. We can plug in the perpendicular distance from point to a line, which is the modulus of ax1 plus by1 plus c all over root a squared plus b squared, and that distance should be equal to the radius. So a is just 3, our x1 is minus g, that's our center, plus minus 4 times minus g, because that's our y value of the center, plus c, which is 6 in this case, modulus of that all over 3 squared plus 4 squared, or minus 4 squared, same thing, is equal to our radius, which is minus g. So I've got minus 3 times g, which is minus 3g, plus 4g, so that gives me a result of g plus 6 all over root 25, which is 5, equals minus g. So g plus 6 is equal to 5g, or minus 5g. So therefore, as this is a modulus, g plus 6 is equal to plus this, or g plus 6 is equal to minus that. So g plus 6 is either equal to 5g, or g plus 6 is equal to minus 5g. So 4g is equal to 6, so g is equal to 3 over 2. That would mean that here the center is minus 3 over 2, minus 3 over 2. Or here the center is, that's minus 1, 1, 1. Now, crucially you're told that it's in the first quadrant, so that has to be the center, and the radius is equal to minus g, which is 1. So this can't be the center here. Don't need to worry about that. So our center is 1, 1, and our radius is 1.